Okay, so I'm going to discuss some terms involving triangles. The first term, perpendicular bisector, we actually already know from when we discussed perpendicular bisectors of segments. It's pretty much the same thing when we're dealing with triangles. It is a line that bisects any side of a triangle and is perpendicular to it. So if I'm looking at this diagram here, let me get a pen here. If I'm looking at the diagram here, this line here is the perpendicular bisector because it's a line. It bisects or cuts this side of the triangle in half or goes right through the midpoint, and it is perpendicular to that side. And there are 3 perpendicular bisectors for every triangle. I could draw the other perpendicular bisectors that are perpendicular to the other 2 sides as well. Next, median. Median is what it sounds like. Median sounds like middle. It is a line segment drawn from any vertex of the triangle to the midpoint of the opposite side. So this segment is the median because it's going from a vertex. Now notice the median has to start at a vertex, a little different than the perpendicular bisector did not start at a vertex. But the median starts at a vertex and it goes to the opposite side, and then it is intersecting with the midpoint of the opposite side. So that's a median. And again, I could draw medians in for all 3 sides of the triangle. Next, angle bisector. So we talked about perpendicular bisector and segment bisector. An angle bisector is what it sounds like. This time the angle is what's being bisected. So it can be a ray, a line, or a line segment, but the point is that it divides the angle into 2 congruent angles. So if I'm looking at this angle here, that angle is cut in half or into 2 congruent angles. Notice the angles are what are marked congruent. So that red line segment is the angle bisector. It's the, in this case, line segment that is cutting that angle into 2 congruent angles. So it's bisecting the angles. So that segment is an angle bisector. And again, I could go to any of the 3 vertices of the triangle and I could draw an angle bisector. Next, altitude. So an altitude is oftentimes referred to as the height of the triangle. Altitude, think high heights, up high, for like when you're climbing a mountain, has a high altitude. So height of the triangle. So it's a line segment drawn from any vertex. So it's similar to a median in that we're starting at a vertex and then we're going to the opposite side. Now this time though, with the median, it had to go through the midpoint. Altitude doesn't go through the midpoint of the opposite side, but it has to be perpendicular to the opposite side. So I start here at a vertex and it goes perpendicular to the opposite side. Now, with that particular triangle, with an acute triangle, it's pretty obvious to see. Well, when we're looking at a right triangle or an obtuse triangle, it gets a little bit tricky. So let's take a look at the right triangle. So if I am starting at this vertex here and I want to go perpendicular to the opposite side, well, that actually means I'm going to go straight down. So the altitude of this right triangle actually is the side of the right triangle because it's the line segment that starts at a vertex and is perpendicular to the opposite side. Okay, lastly, let's take a look at the altitude for the obtuse triangle. So I'm going to start at this vertex. Now when I draw the line that goes straight down or is perpendicular to the opposite side, what actually happens is I have to extend the opposite side a little bit, which is fine. You're allowed to do that when you're drawing the altitude. So sometimes the altitude will actually be outside of the triangle and not in the triangle, which is what happened here. When I drew the altitude, the height of the triangle, going straight from the vertex down so that that altitude is perpendicular to the opposite side, I had to extend the opposite side a little bit. So that's altitude. And again, altitudes could be drawn from any vertex in any triangle. So there are 3 altitudes for every triangle. So let's take a look at a few of those terms in action. Let's take a look at perpendicular bisector. So we know what it is. Let's see how we would use it. So looking at this example, it says that line RS is a perpendicular bisector of segment ZY. Well, right away when I see perpendicular bisector, I'm thinking, okay, perpendicular, which means I know that angle is 90 degrees. So I'm going to mark it. Bisector, remember, means that the side is being bisected or cut in half. So I marked the segments that I know are congruent. So now I'm going to keep reading. So it says ZS, segment CS, or the length of ZS, is 2x plus 2, and SY is 4x minus 4. Well, we just discovered a moment ago that those two segments are congruent. So if the segments are congruent, that means the lengths are equal. So I'm going to set the length 2x plus 2 equal to the other segment's length, 4x minus 4. And I'm going to go ahead and solve for x. So if I subtract 2x from each side, and looks like I want to add 4 to each side, I'm getting 6 is equal to 2x, which means x is equal to 3. And we're talking about lengths here, so 3 units, whatever units this is in. So that's x, so I did the first part. Then it says I'm supposed to find y. Well, let's read the part that discusses y. Okay, so we're looking at the part that talks about the y, the measure of angle RSY. So measure of angle RSY. So I'm looking at that one, whoops, that one there. So I know that that's 90 degrees because I already figured that out when I realized that it was perpendicular. So I'm going to take 90 degrees and set it equal to 6y plus 30 and solve for y. So when I solve for y subtracting 30, I'm getting 60 degrees equals 6y, which means y is equal to 10 degrees. So we found x, we found y. Now it says find the length of ZS. So ZS, well, ZS is 2x plus 2. So ZS is 2 times x, we just found to be 3 a moment ago, and then plus 2. So that's 6 plus 2, which is 8. And then I'm supposed to find SY. Well, SY is congruent to ZY, so SY is also going to be, SY is congruent to SZ. So if I just figured out SZ is 8, then SY is also 8. And lastly, ZY. ZY is the whole entire side length, so I'm just going to take 8 plus 8, or just double 8, and get 16 for the length of ZY. Let's take a look at the next example, altitude. So we have in this example that segment DA is an altitude of triangle ABC. Well, if you remember that altitude is supposed to be perpendicular, that means I'm going to go ahead and mark that I know that that's a 90-degree angle. And it says that the measure of angle ADB, so ADB, is equal to n squared plus 74. Well, I just decided that that angle has measured 90 degrees. So 90 is equal to n squared plus 74. So I'm going to subtract 74 from each side and get that n squared equals 16. To solve for n, I know that I'm taking the square root, and I'm getting n equals the square root of 16, which is 4. So I'm done. I found the altitude, which is, or I found the value of n, which is 4.